Hello and welcome to another SuperNEC Basics help video where today I'm going to be dealing with the output interface and specifically the 3D radiation pattern viewer. So in order to harness the full capabilities of this viewer, which is incredibly useful for later simulations, I'm going to be covering basically all the features it contains in the next couple of sections. The first thing I'd like to cover is basically this slider down here and this little text box. So this is the frequency slider. So you can move your frequency up or down and your radiation pattern will change with the frequency. You can also edit this little text box and you can just select a specific frequency and it'll jump to the closest frequency interval for which data is available. So there you can slide the frequency and you'll see it's changing in 50 Hz intervals, and there we can just select 300 MHz. The next thing I would like to discuss is the component selection. So our radiation pattern viewer lets you select a specific component of your view that you'd like to actually have a look at. You have three options in this regard. You have the major vertical, the minor horizontal, and the total. Slight disclaimer. Currently, the radiation pattern viewer cannot differentiate between the electric and the magnetic fields, and it also cannot differentiate the major minor from the vertical or horizontal components. We will possibly be adding that in the future, but for now, that is how it's going to work. Go down to component, major vertical, you can see it there, down to component, minor horizontal, down to component, and view the total once again. You will have noticed when you opened the View menu that you can also select the coordinate axis, and you have three options: rectangular, polar, or ground. View rectangular. In the rectangular polar view, the data is going to be presented with your phi along the x-axis, your theta along the y-axis, and as always your gain is going to be reflected on the z-axis. Go up, view ground. When you select the ground view, you can actually, in polar or coordinates, you're only going to be showing your radiation pattern as per your ground level. In other words, z is equal to 0. So anything that is reflected in your 3D radiation pattern that has a polar coordinate of z above 0 will be reflected in this view. Last one is polar. As is the case with the 2D radiation pattern as well, if you want to check out that video, this is a true space representation of the 3D polar plot of our actual radiation pattern. So at each point the radius is going to be defined by our gain, and our gain is scaled to the lowest value to have a 0 length. In the 3D RadPad viewer, you also have a couple of plot types you can select from, these being type wireframe. As you can see from the picture we've just shown you, the wireframe is basically a representation of each data point joined by a little wire. So the spaces between the wires are hollow and the hidden lines that are on our plot have not been removed. The next type is mesh. So once again it's similar to the wireframe, except we've actually removed the hidden lines that are inside of our radiation pattern. The next one is the PColor. So PColor basically stands for pseudo-color, in which we're placing a uniform sphere around our radiation pattern and seeing how the radiation pattern is actually reflected around this uniform radius sphere. And this plot is especially useful if you actually want to see how your radiation pattern is reflected upon a uniform surface or at a constant radius from a specific point. And the last one is the surface view. The surface view is basically a complete depiction of the surface as it stands, and the characteristics of the surface obviously are going to be dependent on the shading and lighting properties that we've introduced. Another little nifty trick that we can actually use in our 3D RadPad viewer is, for example, if you wanted to exclude a certain section of your data or certain portion of your data points, you can actually basically cut it or slice your 3D RadPad by excluding everything. For example, in our case, we're going to be excluding everything from phi is equal to 0 to phi is equal to 270 degrees. And we can do that by going to the View menu and selecting Exclude. View, Exclude. And now you'll see in the Exclude menu, you're going to be asked to select two limits. So the first one is going to be for phi, and the second one is going to be for theta. So this corresponds to the angles between the values in your data. So after you've selected your values, you just press enter and it'll display the data excluding the ranges you've set. So for example, it's going to be minus 270 to 270 and 0 to 90. Press OK, and there you can see we've actually excluded the portion of our radiation pattern. Go to View, Exclude, just delete both of those to return the pattern to normal. There it is. As I mentioned specifically for the PColor plot, for example, lighting and shading is an important part of 3D radiation viewing. So MATLAB actually has quite versatile lighting and shading facilities that you can actually control through the Options menu. For example, going up to Options Lighting and Options Shading. Options Shading, you can go Flat Shading. The other one is going to be Interpolated. Options Lighting, Flat. Options Lighting, Gouraud. Options Lighting, Fong. And since we're in the Options menu, let's explore some of the other things we can do. For example, the first thing you can do is edit the title, allowing you to label your plot to your own desires, and we do that by simply going down to Title in our Options menu, editing it and pressing Escape, and it'll have changed the label. Options, Title, 3D radiation pattern, just say 3D radiation. There we go, we've changed it. The next thing I'd actually like to discuss, which is completely separate from the Options menu, is when you're superimposing a structure on a radiation pattern plot, it allows for something called physical interpretation of spatial orientation. So under the View Structures submenu, you can have some control over how the structure is going to be superimposed on your plot. This menu is going to be disabled if the structure has not been passed into the radiation pattern viewer. So if you want to go back to that, we have an input menu video that we've done earlier. So this is actually going to be selecting whether the structure should be superimposed or not. Go back to Structure, say Line Width. So line width is basically working a lot like the line width in a Word document, for example. You can make it thicker by setting the number higher, etc. Okay, and now go down to View, Structure, and you can scale your structure to a specific value if you so wish. And it's obviously relative to the surface. Okay. The other two options that I don't usually fidget with too much is color and XOR, but I'm not going to be covering that in this specific video. So the next handy dandy little tool I'm going to familiarize you with is the 2D cutter. So obviously you might want to take a little slice of your 3D pattern and show what it looks like in the 2D domain, and you can actually do that. And the first thing you'll notice is that there's an unticked checkbox that enables or disables your ability to take a two-dimensional slice of your 3D radiation pattern. So you tick it, and now we have control of how we're going to slice our 2D radiation pattern. So you'll see there's a pop-up menu right here that says Phi at the moment. So you can select Phi or Theta, or in other words, the elevation cut, so horizontally, or the conical cut, vertically. So you'll see I'm on Phi, meaning I've cut it straight from the top. Change it to Theta, and the next thing we're going to be doing is we're going to be setting the angle at which we're going to cut our data set, which is going to be set through this edit box or this slider right here. Or you can just use the slider and you can see it's moving the cut down. By pressing the 2D button, you're basically going to be passing your data to the 2D radiation pattern viewer. Press 2D, and you can see there we have a 2D radiation pattern. I'll be covering 2D radiation in a later video. Have a great day.